Hello everyone, good morning. I am Sangeeta. I'll be presenting my project titled Smart Factory IoT Monitoring System. This was developed during my internship at MITETS. I am a student of Aeronautical Tech Engineering College, a second year ECE student. Let's move to the next slide. Introduction to IoT. IoT stands for Internet of Things. It refers to connecting physical devices to the internet so they can collect and share data. This allows us to monitor and control systems remotely. It is widely used in areas like smart homes and industrial automation. It enables us to control everything from different places. So let's see the next slide, which is the problem statement. And looking at this, in industrial environments, monitoring is still not fully automated. Because of this, changes in conditions may not be noticed immediately. This led to inefficiency or even damage. There is a need for real-time monitoring and faster response. And that's why I have built this project. Objectives of the project is to build a smart monitoring system which continuously tracks environmental and operational data. It also performs automatic actions and allows remote control through the cloud. And what about the system overview? Looking at the system overview, it consists of two nodes. Those nodes are production line, that is production line node 1 and warehouse node 2. Both are implemented using Arduino in a simulation environment. The simulation environment is PICSimLab, that is the one that I have used, and the data is transmitted using MQTT and visualized in a cloud dashboard. The cloud dashboard that I have used is ThingsBoard. And coming to the next slide. The next slide is about node 1, that is the production line. In a industry, there will be a production line, and to monitor that, we are using this node. In this node, the production line node monitors parameters like temperature, humidity, machine temperature, and vibration. It uses the sensors like the LM35, DHT22, DHT22, which is the humidity and temperature control. And it also shows machine on and off detection, relay control. It has LED indicators to alarm us. And okay, now let's go to the next slide, which is the warehouse node 2. And in the warehouse node 2, it monitors environmental conditions such as temperature, humidity, light level, motion, and door status. It includes an automatic ventilation system that activates when humidity exceeds a threshold level. The door opens and closes when we switch it according to our wishes. And next is the system architecture. Looking at this, we can say that the system is following a simple data flow, and the sensors collects data, send it to the Arduino. Then from the Arduino, it connects to MQTT and publishes using MQTT. Cloud platform then receives it and displays it on the dashboard. The control commands are then sent back using the RPC. Next is the simulation environment. The simulation environment that I have used is PICSimLab. This entire system is implemented using a simulation environment, that is, I haven't used the physical hardware. So the sensor values can be adjusted and the system behavior can be observed in real time. Let's look at the dashboard. The dashboard displays all the telemetry data in real time. It provides visual indicators, charts, and also the status updates. It gives us how the relays are working, or if it's the sensors are working correctly or not and all. This helps in monitoring the system remotely with fire, even if we are very far away, and efficiently. And the next one is remote control using RPC. Okay, this is implemented, the remote control is implemented using RPC. Through the dashboard, we can send commands to the device. For example, the relay can be turned on or off remotely. This enables the real-time control of the system. That means we can control from anywhere. We can control our industrial functions and all. What's next is automation logic. Okay, here the automation logic is implemented based on threshold conditions. The threshold conditions are, example, when the humidity is greater than or equal to 85%, it triggers an alarm. Then the ventilation system will be activated automatically. This reduces the need for manual intervention. We no need to go to that on site. Next is the code structure. In the code structure, the code is organized into multiple modules, many modules to make it easier to understand, like sensor handling, actuator control, network communication, and telemetry. Everything are separated, kept separately. This modular system makes the system easier to manage, and we can extend it. And let's see the learning outcomes that I have experienced to this project. I gained a lot of experience, practical experience in the IoT design. I have worked with Arduino, sensors, and MQTT communication and cloud integration. It also improved my debugging and problem solving skills. It's a very new experience to me. And let's see the conclusion. This project demonstrates the real-time monitoring, automation, and remote control. It's scalable, and these are essential features in model industrial IoT systems. The system can be further extended for real-world applications too. And this has multiple nodes which will be very useful in the industrial environments. So this is the end of our PPT presentation. Let's go look at our PICSimLab. Here at the PICSimLab, we can, okay, I'm going now, clicking at it. Here's the PICSimLab environment. Okay, this is the simulation of the production line node 1. You can look at this. All the sensors and actuators are connected virtually in the environment. It's in the on condition. Now we can look at this temperature and humidity. Here you can move it. You can move the temperature. You can adjust it. When I change the values, you can see the reading updated in real time in the dashboard. And now we can move the LM35. Where is it? Yeah, it's here. Okay, when we change the LM35, you can also see the readings in the dashboard. As the value increases, it reflects the heat generated by the machine. Then we can see here's the vibration sensor, and vibration sensor change analog input. It's based on analog inputs. This input simulates vibration. The multiple ratings are averaged in the code. We can to avoid fluctuations. Then that's what we are seeing is the machine control. It has the machine. It shows the machine status. It has a press button, and this button represents the machine if whether it's in the off state or on the on state. And since it is active now, pressing it indicates that the machine is on. Now here's the relay status. This is the relay output. It represents control over the machine or external equipment. We can see the RPC demo here. Here's the dashboard. When I switch control off, you can see that in PICSimLab 2, the relay status has gone off. So this is the RPC control. We can control from the dashboard remotely the PICSimLab. The relay status has gone off. Now here, okay, when I toggle the switch, the relay updates immediately change in this simulation. And now here the LEDs are there. Green LED is to show that it has no errors at all. Now let's go to the node 2. We are loading the workspace. Here I am going to the node 2. Okay, I'm adding it now. Cancel. Okay, I have now looking at the spare parts. Here is it. I have done, and now let's load the heads file. Here I am loading now. Okay, yeah, here is it. Yeah, I have done, and now it's the simulation environment of node 2. This is the warehouse node 2 simulation. It focuses on environmental monitoring and safety related parameters. Now we can see the sensors and all. Here too is we have the DH22 temperature. We can vary the temperature, and it's the sensor for humidity. As you can see, when we are lowering this humidity levels, the ventilation relay has gone off, and we are taking it back to high. It will now, it got on. So this is the control over the ventilation relay. And now we can see the LDR sensor. It's the light sensor. Where is it? Yeah, here it is, the LDR sensor. When the value drops below a threshold, the system detects it as dark. When it has a threshold value, now system has gone dark, and now the system is very bright. Okay, the PIR sensor. Here is the PIR sensor. This is the motion detectance sensor. It triggers when motion is detected. The system remains active for a few seconds to avoid the rapid changes. We can click it like this, and this is the simulation. Now we are going to the door switch. This is the door status. The door is closed, and now the door is open. We can toggle at the switch, and looking at this, we can also see it in the ThingsBoard dashboard. Now this is the warehouse node 2. Here, yeah, look at this. The door is on now. This door is open. So here in the production PICSimLab, this now is the door is open. Here now the door is closed. Then we can see the automation. When we increase the humidity, when it crosses the threshold, the ventilation relay gets on. And we can also control this ventilation relay through the ThingsBoard when we do the switch control. And now now this node demonstrate the environmental monitoring along with automatical control. Even though this simulation this is a simulated setup, the behavior is simulated similar to a real industrial system. So both are same, just that we haven't used a physical devices. Now let's go to the ThingsBoard explanation. Here it is. First take a look at the devices. The devices I have used are warehouse node 2 and production light node 1. Both are active now. These are the alarms that I have added. These are the alarm rules that I have added. for high humidity alarm, high temperature alarm, for both the production line node 1 and for the warehouse node 2. It gives the two keys like warning and critical. So looking at the dashboard here in the production line node 1, now I'll show the cloud side of project used in the ThingsBoard. This is where all the data from the board nodes is collected, visualized and controlled. Here the latest telemetry can be seen from the data coming from the device. All the sensor values are updated every few seconds. This is the dashboard designed for the monitoring of the system node 1, and here parameters are shown. These are the gauges, temperature gauge, and this is the humidity gauge. The values are continuously updated based on the sensor readings. And these are the charts. This is the chart. Chart shows the historical data in which helps in analyzing the trends over the time. And looking at the machine status, it's on. It indicates whether the machine is on or off. And it's the relay control. No, it's the relay state, and yeah, this is the sensor error. If the sensor or the production line or anything has errors, it shows on at the green light. Okay, now let's see them. This is the ventilation override. We can switch it on and off. Using this control, I can remotely turn the relay on or off. This demonstrates the real-time node using RPC. Let's have a look at this. Oh yeah, okay, wait, I'm taking this in PICSimLab. Here I am again taking the node 1. Now load workspace. Node documents. Okay, now node 1. Here PICSimLab node 1. Let's add this. Yeah, here spare parts. Now it will get on. Okay. In the spare parts, we can look at this. Okay, here it is. And I am showing the RPC control again. Load the heads file. Of the node 1. Here I have loaded the heads file of the node 1. So let's see if the relay is going on or off. Here it is. We can ventilation over. If we on here, it's too gets on here. Look at this. And if we on here, off here, the ventilation and the relay status has gone off. So this is the RPC control. Now, okay, here in the production line node 1 and so this node mainly focuses on the monitoring and controlling the production load line. Here is this time series table. We can see all the values that I have shown. This is the machine status, LM35 temperature, humidity, and relay state sensor are 0. There is no errors, and this is the vibration values. Here it's changing, right? Look at this. And here this is the alarms that I have created for this node. Okay, and now we are going to look at the dashboard of warehouse node 2. In the warehouse node 2, here the door is on. This shows the humidity and the temperature. And let's see the light. This is the motion of it shows it's a widget for the PIR sensor. And this is the ventilation override. We can switch it on and off. Now looking at the time series table, you can see all the values plotted here, and this is the LDR value. It's last updated 37 seconds ago. The warehouse is now dark because the LM35 value is very low. No, LDR, yeah, that's LDR value. And the relay state is off. You can see the time series chart of this, and the alarms that I have, that it's shown, it's showing the critical, it's that temperature is very critical and humidity is too in the critical stage. Now we can see, yeah, this is for the RPS as RPC handling. I have shown it for the node 1, and let's see the smart factory dashboard. Here both the node 1 and node 2 both are mixed here. This is for the production node 1, this is for the warehouse node 2. This is the time series chart for both the temperature and humidity of node 1 and node 2. Now let's, okay, I have completed everything here, I think so. We can see the code side. Now let me open the code for node 1. Here it is. Now let's explain the code for the production line node 1. The code is divided into modules so that each part handles a specific functionality. This is the sensoring. In this node, that we can see the sensor manager.cpp and sensor manager.h, and there is one more. Okay, that's it. These both manage the sensor includes temperature, humidity from the DHT sensor and machine temperature using the LM35 using the LM35 and vibration using the analog input. And for the vibration, multiple readings are averaged to get a stable value. Machine status, there is also a digital input to detect where the machine is on or off. This is the vibration for this. This is for LM35 and sensor data, everything here. Here is the machine status, if it's on or off. And actuator control, you can go to actuators.ccp and actuators.h. You can see all the white code here, and the actuator section controls the relay and LEDs. I can give yeah, look at this. These are the LEDs for the code for LEDs. And now the relay represents the machine control. The LEDs indicate normal, warning, and or critical state if it is. Here look at this. If there's if there is no error, then the green will be high and yellow will be low. When a command is received from the dashboard, the relay state is updated accordingly. Here you can see the code for this here, and this function updates relay state and it also reflects it in the output pin. Now let's look at the telemetry. In the telemetry, all the sensor values are packaged into JSON format and sent to the cloud at regular intervals. Yeah, here this part is in the JSON format of data. In error handling, if the DHT sensor fails, the last valid values are reused and the sensor error flag is set. Here look at this. And overall, this node focuses on monitoring machine conditions and enabling more remote control through the dashboard. Now let's go for node 2. Here, yeah, we can see that. Okay, and now I am taking for the node 2. Here it is. Okay. Now let's explain the code for the warehouse node 2. This node focuses more on environmental monitoring and automation. The sensor handling, sensor manager here, sensor manager.h and sensor manager.cpp. The sensors used here include temperature and humidity, the LDR for light detection, and PAF for motion detections, and read switch for door status. Here it is door open, read door. And for LDR, multiple threshold values are there. If the value is below a threshold, the system identifies the environment as dark. Yeah, look at this. This is the part of that. And for motion detection, A whole logic is implemented. Once motion is detected, it remains active for a few seconds to avoid the rapid fluctuations. Where is it? Yeah, here. Look at that. And okay, now the automation logic, we can see the automation logic from the telemetry side, telemetry.ccp and telemetry.h. Here too we are sending the JSON format of data. And now this node demonstrates how environmental monitoring and automation can be combined in a smart system. Both nodes follow the same architecture but are designed for different use cases. This is the end of our presentation, and thank you to the Emirates company. Thank you for giving me this opportunity. Thank you, Emirates. Thank you a lot. Thanks a lot. And I have a very special thanks to my mentor Jayalakshmi Daniel. I am very thankful to her for continuously mentoring her and her constant support. I am very thankful to her. Thank you, ma'am. This is the end of the presentation. Thank you.